Okay, in this video we're going to continue on. This is phase 3, the mechanics phase. And let me go ahead and switch back over to my implementation plan. There we go. So we're going to start out here first by skeletoning in several methods. Let's go ahead and start out with our mechanics area where we've got 3 different methods to get skeletoned in.
Okay, we've already begun the mechanics method from before when we had the update player, so we'll jump down and jump right below update player.
Okay.
Now,
check fire.
Alright, this is going to be a private void method called check fire. And we'll block that in. Alright,
okay.
next.
Now we've got reset target.
Okay, again, private void reset. Let me capitalize that. Reset target.
Okay, and then finally for our mechanics section we have got reset projectile.
Alright, we've got private void reset projectile. And jump down, space that out.
Okay, now we're going to be moving over into our collision methods.
Okay, let me make a region for collision stuff. So
okay.
Region, collision, and the region. Alright, collision methods.
Alright, starting with check ground collision.
Alright, again, this is going to be a private void, and it's called check ground collision.
Okay, and then we've got check air collision.
Alright, private void check air collision. And let me capitalize the C on collision.
Alright.
And block in the method.
Alright, now it's time for our utility methods, which is really just a utility method.
Alright, let me define a region for that. So
you
we
bet.
have a region for utility methods. And in the region.
Oh, you better go back up to the region for collision then and put collision methods up there.
I see, I was almost wondering about that.
Thought you was going to get one by. Alright, so in here let's go ahead and set up our distance method.
Okay, it's going to be a private method, but it's going to return a float. So this will be private float distance. And we also need to take in some parameters. We need to take in a point for point A and a point for point B. Block that in. Now, of course, let's see. And just to get the skeletoning in part, I'm going to put return 0. And
just so that everything works if we call on it.
If we were to build.
Yeah.
And now this should look very familiar because it should be the same distance you've seen from Canon 1.
Alright, well, to be honest with you, that takes care of the first part of the implementation plan in this section. Now let's go ahead and move on. Now this is where we're going to get into the meat of things quickly. Now we're going to focus on creating our target item. So we need to create our target and then initialize it, set up the texture, load the stuff, update it, draw it. Then we got to get reset and checking collisions. Oh yeah, this is where it all comes to life. So create our target item.
Alright, let me jump back up to the variables section right below our game item player. We'll define a new game item, this time for the target. So we've got a variable to hold a reference to a target. Now let's jump down to initialize and create
the
a game item for
game item.
Alright, this will be our target is equal to a new game item.
Alright, good deal. So now we need to, yeah, you're already there.
Now we need to load the graphic into the picture box and then associate the picture box with the target. So let's take our target picture box. Let's have it load the graphic for the target. So we'll load target.png. And then we'll turn around and we'll take our target game item, set its texture to the target picture box.
Okay.
Alright.
Now we need to focus on update and draw.
Alright, we need to update and draw our target. So let's jump down to update scene where we can say target.update. Easy enough. And now,
and again, just as a recap, the reason Logan's doing a target.update here is because now we can rely off the game item's regular update method where it's going to take that velocity information and add it to its position information. Remember, with player, as Logan said earlier, that's a special case where the player's position was being driven by the mouse, not the velocity. Okay? Just wanted to point that out again. Alright, so, draw.
alright, let's draw our target. So we'll take our target and we'll call upon draw.
See how nice it is, guys, having these encapsulated inside objects, basically, having all this, or the method, the behavior encapsulated inside it, so we can just say, player, you draw. Target, you draw.
Which is a lot more convenient than having to do something where we take, what was it, 4 different values into account for for the actual drawing, whereas here it's one simple line.
And we don't have to worry about it anymore. All right, beautiful. Okay, so now that we have that set up, it's time for us to go ahead and focus on resetting the target.
Right, because if we were to run now, as a matter of fact, even before we get reset target in, I wonder if we could prove that this much of it is working. Like, if we run, obviously, there's no velocity set. So if we build and run now,
it just sits there. But there it is, 0, 0, so that's cool.
And just to prove that it's working, I could go back to the target here.
Sure.
Now, we're not going to keep this, but if I just took our target and I set its velocity to something, like if I just make up a new point and give it a velocity like maybe 5,2 and run. And
there it goes.
So we have our target as a moving game item.
Awesome.
Even though it disappears off the screen and then is never seen again. As a matter of fact, let me actually change it now. Point it down faster. And you can see that, of course, we don't have a reset target, so we just disappear off the bottom of the screen.
Right.
All right.
But everything is indeed working.
Right, we've got, and that was actually a rather quick setup to get a moving object in. We just made it and did a very standard procedure with update and draw, and we have a moving game item.
Yeah, very nice. Okay, so now you ready to go and start focusing on resetting the target?
Yeah, now we need to get the target behaving like the target is supposed to, and that means resetting when it hits the bottom of the screen. So let's take a look at implementing reset target in Canon 2. Now, reset target's code is going to be similar to Canon 1. As a matter of fact, I'm going to switch over to Canon 1 and grab the code that's within the reset target method. So let me jump down to mechanics stuff where we should have reset target. Grab all of the code inside of reset target. And jump back over to Canon 2 and paste that in. Now, of course, there's a few things we'll need to change, like the fact that we don't have a target velocity x and y anymore. Now, since we do want to work with the velocities individually for a while, I'm going to define some local variables inside of reset target until we're ready to take the final velocity and set that for our target. So I'm going to change these to local integers. So I'll have an int velocity y. Actually, we'll start with x.
Yeah.
Velocity x, and then our we'll do a second one for velocity y as well. So int velocity y.
Okay.
And then I'll take velocity x, we're referring to that again inside of the random, so I'll replace that here. And now we need to worry about setting our position. We're not addressing a top and left because our target game item doesn't have a top and left. So we can take all of that and erase it, since some of the things aren't even relevant. We need to worry about origins now instead of height. So let's first set the position and then take the velocity into account when setting for the target. So first off, we have our target. We'll set its position to be equal to a new point where x will be the center of the screen. So it needs to be the screen width divided by 2. And where the height will be just enough so that it's off screen. So we'll take its origin and take the negative value of that. So that way it's far enough off screen so that it's no longer visible.
All right, it's already halfway off the screen. Now you can just push it the rest of the way.
Right. So we grab our target, take our target's origin, and take the origin y value. And that should set our position. And again, with our positioning being center of our game item, we only have to take the center of the screen. We don't have to worry about any further offset for getting the center of the game item.
Okay.
Alright, that takes care of position. Now we need to make sure we remember to set our velocity, because in the old game, in Canon 1, these were the actual velocity variables in use for the target. Here they're just local variables, so we need to remember to store them in our target's velocity. So we'll say that our target's velocity is equal to a new point where we will store velocity x and velocity y. And that should do the trick.
That's it.
I'm going to go ahead and build now to make sure that all of this was brought over and works now. And it does.
And did you leave the values in up above where you assigned it a velocity?
I did, so it would be a good idea.
So you can just test it.
Oh yeah, that's right, so it should already be moving. So
well, actually, no, because
there's a few more things. Nothing.
Yeah, we're not quite there.
Nothing ever calls reset target.
That's right.
So when would reset target get called? Well, when it hits the bottom of the screen.
So now's a good time for us
to
go ahead and put some check ground collision into place.
All right, let's move down to check ground collision. And while this may be similar to the old Canon 1, it's
so
simple
small
enough that I'm just going to rewrite it here.
Okay.
We need to do a check and see if the bottom of the target has hit the bottom of the screen yet. And in this case, since it's convenient that we have a bottom property for the physical visible picture, I'm just going to go ahead and use it. I mean, why not? We have the items there. We can use them. Or, I mean, the picture boxes. So let's take our target picture box's bottom. See if it is greater than the screen height. And if it is, then we know we've hit the bottom of the screen and need to call, well, in the end we need to call kill player like in Canon 1, but we don't have a kill player yet, so just to make sure everything's working, I'm going to call upon reset target. So there's our reset target. So now we should be able to see something happen, providing we are indeed checking for ground collisions.
That's right.
Of course, we need to call that before we try to use it. So where do we put that in order to make it work in our new engine system?
Go back up to update. There we go.
So we'll call this from update. We'll call it after we've updated all of our game items. So we update the game items and then check to see if that update resulted in a collision. So we'll check our ground collision. So check ground collision. There we go.
And now we can test.
All right, let's run. So those are our temporary initial values. And there we go.
All right.
We hit the bottom and we start running. All of the randomization code remains the same, but now we're setting the velocity of a game item instead of just setting simple velocity variables.
Oh, that's just fantastic stuff. All right. Well, that takes care of getting the basics into place for our target item. Let's go ahead and start focusing on our projectile.
Okay. Now let's begin with making a variable to hold a reference to a projectile. So let's jump back up to the top, and right below our game items, let's make a new game item for projectile. So we have our projectile variable.
Now let's initialize.
Now we can jump down to initialize, and jump below where we're doing target stuff. So in fact, I'll jump back up a line, and say that our projectile is equal to a new game item. And then we need to turn around and load the graphics for our projectile. So we'll take the projectile picture box first. Projectile picture box. We'll tell it to load in the file projectile.png. And then we'll associate that with our actual projectile game item. So projectile.texture is equal to projectile picture box. Alright, now we need to remember to update it and draw it. So inside of update scene, we'll take our projectile and we'll tell it to update. And inside of draw scene, we'll tell it to draw. Projectile.draw. Alright, that has all the engine stuff in place. Though, thinking about it, we need to set the projectile's speed at some point, and since it's always going to have a constant speed that doesn't change, I'm going to set it right after it's created inside of initialize. So as soon as we create the projectile, I'm going to turn around and set the projectile's velocity to a point. That point is going to be 0 in x, because it doesn't move side to side at all, but it does move in y. It moves at a rate of negative projectile speed.
Okay.
And so we have our velocity set up for the projectile. Now we need to worry about things like making it fire, because of course if we run the game now with a velocity, it's going to start at the top of the screen and immediately disappear off screen.
Exactly.
So let's see, what do we need to do?
Now that we have that, next thing, check fire.
Well, yeah, with the projectile, it gets reset whenever gets fired whenever the mouse button is hit. So we need to focus on check fire now and look at how we go about seeing if the mouse button is currently down.
That's right, because once again, we're not relying on a mouse down event to say, hey, mouse button's been pressed. Now we're going to have to poll the state of the mouse button.
Right. So let's begin a check. And let's say that if the mouse button, or let's say that if the left mouse button is currently down, and like when we were in update method, or update player, excuse me, we had mouse position we could look at. We also have mouse buttons. We can say that if the mouse buttons are equal to mouse buttons.left, that means the left mouse button is down. Now, of course, we need to also have the consideration for where the projectile is and not allow a refire if it's currently on the screen. So we need to see if the mouse button is down and if the projectile is off screen. So if the projectile picture box's bottom is less than 0, then it's off the top of the screen.
And if that is all true, then we are in a state where we can fire a projectile. And what is firing the projectile? Well, simply moving it down to the nose of our ship so it can begin its journey up the screen.
Alright, so much like we had done in Update Player, let me set up 2 integer variables to hold our x and y before we turn around and set that for the projectile's position. So let's first get our projectile x. So int projectile x. Now that one's going to be simple. That is just whatever the player is currently, or wherever the player is currently at. So we can get our player game item and ask for its position, but of course we're only using the x position right now. And then y is going to be a little bit trickier because we have to worry about some offsets. But first, let me put in a variable called projectile y to store that. Now, what does the projectile's y position need to be? Well, it's going to be aligned to the bottom of the screen because that's where the player's at. But we also need to account for the player's own height and then make sure that we center up for the projectile's height as well. So we'll begin with screen height. But of course, we need to move up a little bit from that because we don't want to be centered on the bottom of the screen. So we need to take an offset, so we'll take away the player picture box's height. So basically, for now, we'll align to the top of the player picture box. So let me put that in place. Minus player picture box dot height.
Which means we'll have half of the projectile drawing over the tip into the ship.
Right. So we need to account for the projectile's own height. Now, of course, we have to worry about the projectile now in a centered fashion.
That's right.
So we want to look at its origin and just take away origin's y.
That moves that last half up and off of the nose of the ship.
Right. So we'll take our projectile dot origin dot y. All right. And that should actually terminator, not parenthesis. And that should take care of where we want for projectile y. Now we need to turn around and store those in our projectile's position. So projectile dot position is equal to a new point. That point is going to be at location projectile x by projectile y. Alright, that should take care of checkfire.
Fantastic. Which brings us down to, we need the ability to check air collision. But, do you want to test some of this now?
I do. I want to make sure that this is, in fact, working and setting the projectile properly. So, before I run, I need to make sure that checkfire is called from our engine update.
Okay.
So I'll jump back up to update scene, and even before we start updating things, let me do a check fire. And this is how we had it originally set up, but I'm actually thinking of moving it below, because here's what I'm thinking right now. We update the player, which means the player's position could have moved, but that's after we've checked for fire. I almost think it would make more sense to move this afterwards, because that way we have the most up-to-date player position when checkfire looks at the player. So let me go ahead. So we've got our for updates, our checkfire, and then we check for ground collisions. So let's update and see if we can fire. And indeed we can, though it looks like there's a positioning problem. It seems that the projectile is spawning from the center of the ship. Now to show that more quickly, let me go up and temporarily set our projectile's speed to 0, just so we can see, or just so that it'll stay where it's currently spawned at. And it's spawning from what looks like below the bottom of the screen. So let me see what we used. Maybe we accidentally used width or something instead of height. Alright, we've got screen height, we've got X and Y lined up. So we've got our screen height, then we offset. Actually, let me comment out the rest of that for now. Let me just set it to the screen height and see what happens. And we get in projectile Y, so our projectile's position is set, and X and Y. Let me think, Y is that setting? So it equals minus screen height. So it's actually spawning below somehow. So we've got projectile Y, projectile, dot position.
I'm not catching it right offhand.
Minus picture box dot height. Let me set the projectile speed to very slow so I can see how quickly it is, or how quickly it comes off the bottom of the screen. So it's like it's spawning pretty much at
Well, just go ahead and throw a breakpoint in there, and let's take a look at when you actually fire. What is that height? There we go.
Screen height should be 480, which is correct for the size.
Now let's go ahead and find out what. Yeah, that's correct there.
All right.
So now let's go ahead and put the rest of that in.
And see where that's leaving
Yep.
it. That's already odd, though, because that should be showing it halfway through the bottom of the screen.
But is it perhaps right behind the...
Well, it might be right behind the frame border, because the problem is the form itself has a frame border.
That's correct. So, yeah, let's go and do that. Run again. And so that's...
Projectile picture box height is 8. Origin Y is 4. That's all correct. So screen height, so projectile Y is 0. Step across 460.
Wait a minute. You don't want to do the projectile picture box. You got the player. Yeah. That was great. The number wasn't adding up in my head. It's like you need to be moving more than just 8 pixels.
Right. Looking at the wrong thing. Looking at the... Then that would explain it, because the projectile is, of course, a lot smaller. And we need to visually account for the player. So if we account for the player, this should now have a spawning. As a matter of fact, let me set the speed all the way back to 0 just so we can verify that position. And, oh, it's not moving all the way off screen. That's weird. Basically what's happened is
it's the 0, when it gets caught by the update, since it's not off the screen, which you can do that. You can fix it real quick, close that, and go down to your check fire. And...
Check fire.
And there you go. So you're looking for the mouse to be less than 0. Make it less than 10.
So less than... That should be playing because it's only like 4 across.
There you go. And
so now it sets perfectly.
Yep. Good deal. All right. So now go ahead and change that back. And, oh,
wrong thing.
Less than 0. There we go.
And less than... Now we need to go back and change our projectile speed to 12. And now that has...
So a quick recap. Basically what was going on here, I'll just grab a mouse real quick, Logan. And, well, if I can, it's stuck to the desk. There we go. So basically all that was going on is we started getting so carried away with these picture boxes. They all look the same, and we threw projectile instead of player in there. But it actually worked out as a great example because it showed how going into debug mode can be so helpful. Because in that particular case, I wanted Logan to jump into debug mode and check these values. And as he was checking the values, and what I saw was like, wait a minute, 8's just not enough to move it up because the player's 32 pixels. So we need it to move up all the way to the top of the 32 pixels. And that's when I was like, oh, wait a minute, it's not player, it's projectile, so we're getting the wrong value. So debugging can be so helpful. All right, very cool. So now that we have that in place, and it is firing just fine, so let's go ahead and run it. So it should be firing at normal speed now, and everything looks right. Perfect. Okay, so now that check fire is working and we are able to fire, let's go ahead and focus on check air collision.
Right, because right now if I hit the target, the projectile just goes straight through it.
Yeah. All right, so check air collision.
All right, let's jump down to our collision section, and we have our check air collision. Now to show the convenience of having the centered position, let me actually copy the code from Canon 1.
Okay.
And we'll rework that into the Canon 2 positioning system. So let me jump back to Canon 1. We have our check air collision, so I'll grab the whole entirety of the code within check air collision and paste that inside of our new check air collision. Now because positions are centered, we no longer need to worry about getting a center before we check. So we can take both of these temporary points completely out of the mix.
Very convenient.
And we're checking the distance of the projectile's position against the target's position. So I can say that we're checking, all right, for distance we have our projectile. It has a position. So a position is a point, which can be fed to distance, which is taking in a point. And we have, we need to compare that against target. So we need to get the distance to target. So position, our target dot position. And that should also be a point we can feed to distance. So now if we build, everything, let's see, build except for...
kill, yeah, doesn't exist.
Right, we don't have that yet. So I'm going to comment it and instead put in reset target. So there's our reset target. I'm also going to make a call to reset projectile, though we haven't coded it in yet, but I do need it here in the collision.
Correct.
So if we build, everything now builds just fine. And if we play... we won't get any collision because we're not calling check air collision from anywhere.
That's right. We need to call it from within our update scene.
So I'm going to jump back up to where we did our ground collision and just jump in before that and do a check air collision. So now we should be able to run and test and see the projectile. That's interesting. I wonder, let me think. It's like it's always colliding. So projectile position against the target position. We are still spawning off the, thought we were still spawning the projectile. Let me set a breakpoint and reset target. So we are in fact still doing that. Let me see if we're ending up inside of check air collision for some reason. And I think I see why. Because we're jumping ahead. What is this distance going to be whenever we check the air collision? Whatever distance returns. What does distance return?
Always 0, which is always less than 20. Which
and
is
then
what
collision
our
distance is going to hold 20, so it's always going to occur. That means before we can test
we
and
better
see
get distance running.
any working result, distance needs to be coded in.
That's just too funny. Okay.
So let me jump back to Canon 1 again, because the distance is pretty much exactly the same. We're doing the exact same thing with the points and returning a float. So I'll grab all of the code inside of distance and simply drop that into place, overriding our temporary return.
Okay.
So now we can build,
and
everything
that's
is fine.
Work.
And now we're not always colliding with the target because target has distance has a meaningful value in it.
Right.
By now I should be able to shoot down the target.
Yep. Of course, we're not going to reset our projectile yet, but we will reset the target.
Right, because reset projectile has been coded in, which we could go ahead and do that then. Go back up to reset projectile and get this coded, which is a simple matter of moving the projectile somewhere off the top of the screen. So we could take our projectile, we could set its position to be a new point, and in X, we don't care about where it is in X as long as it's off the top of the screen, so I'm just going to put in 0. And then for Y, we'll do negative projectile dot origin dot Y. So move it just enough to be completely off screen.
Perfect. And we can test.
So now if we hit the target, then both projectile and target get reset.
Awesome.
So that has...
That's it.
Yes, that has mechanics, because again, the game is now at a running state. We have a moving player that shoots projectiles, and those projectiles can collide with the target and cause the target and projectile to reset.
Okay, so a quick recap. Basically what we did, again looking at the implementation plan in this video, we started out by skeletoning in several methods. We did our mechanics methods, which were check fire, reset target, and reset projectile. We then moved on to our collision methods, which were check ground collision and check air collision. And then we did our utility method, which was distance, where we told distance to return 0, which bit us a little bit later on, but it allowed us to compile the code just fine. So that was actually an awesome example for you to keep in mind when you set up skeleton methods like that and you have them return values. Always remember, what are they returning if you have not coded them in yet? And then after getting that all set up, we then turned around and we started to make more stuff work within Canon. We took a look at getting the target up and running by first creating the target object, and then in Initialize we went in there and actually created the new game item that was going to be the target. We then loaded its texture, we made it update, we made it draw, then we coded in reset target, and then we coded in check for ground collisions, and we called check for ground collisions from our update scene method and made sure all of that worked. From there we turned our attention over to the projectile item by doing the exact same thing. We went ahead and created a new projectile that was a game item and loaded its texture, associated the picture box with the projectile object. We then did its update, its draw. We then coded in check fire. We then coded in check air collision and called it from our update scene. And then we coded in distance and so that would actually work right. And then finally we went back and coded in our reset projectile so that everything looked right. And now the mechanics are all working beautifully. Of course, Logan can sit here and play it forever, and the game will never end, or it will not get more difficult. And that's just the way it goes because we're missing all of our game logic and all. So in the next video, we're going to start focusing on all of our gameplay methods. So that is going to wrap up this video. Thanks a lot.